Have you ever gazed up at a clear night sky, feeling those tiny pinpricks of light evoke a rush of wonder and curiosity? As you contemplate the vastness of the universe, the question lingers: how do stars, magnificent beacons of light, actually come into existence in this grand cosmic playground? Hold on to that thought, because in the next few moments, we're going to journey deep into the heart of the cosmos, revealing the spectacular processes unfolding in stellar nurseries. By the end of this exploration, you'll have a heightened understanding not just of stars, but of our place in the universe, and trust me, you won't want to miss what comes next. Stars form in vast clouds of gas and dust known as nebulae, which are found scattered throughout galaxies. These ancient, swirling clouds are teeming with materials left over from the universe's earliest days. You might be surprised to learn that the very ingredients for life, like carbon, nitrogen, and oxygen, are birthed in these stellar nurseries. Imagine that. The raw materials floating in these clouds provide the essentials not only for stars but for planets and ultimately, for life itself. It's a cycle of creation replete with beauty and complexity. So, how does this cosmic process actually begin? Picture this: a region within a nebula becomes denser due to gravitational forces at play. This density creates what astronomers refer to as gravitational instability. It's akin to a snowball rolling downhill, picking up speed and mass. As more particles collide and stick together, a small clump of gas and dust begins to form. It's fascinating to think about, isn't it? A universe of potential condensed into a tiny speck gathering momentum. Now here's something unexpected. As this clump grows, it doesn't just passively gather material, it begins to heat up due to the gravitational pressure piling on. According to the laws of physics, compressing gas heats it, much like squeezing air in a bicycle pump. As the clump heats up, it transitions from a simple dust ball into a protostar. Exciting, right? The stage is being set for what will eventually burst into the brilliant radiance of a star. At this point, you might be wondering what happens next. You're right to be curious, because it's about to get even more intriguing. Once the protostar's core temperatures rise dramatically, crossing about 10 million degrees Celsius, nuclear fusion ignites. In this breathtaking moment, hydrogen atoms fuse together to form helium, releasing an enormous amount of energy. Imagine. In an instant, this energy is what transforms the protostar into a full-fledged star, shining brilliantly against the backdrop of the cosmos. But the wonder doesn't just stop there. Stars don't exist in isolation, they form in groups called stellar clusters, which can comprise hundreds to millions of stars, all created in a similar tidal wave of gas and dust. This suggests that the universe doesn't just create one star at a time, it showers us with starlight, filling the cosmic canvas with vibrant colors and formations. Each star birth carries with it stories of formation, struggles for existence, and interactions with its cosmic neighbors. The implications? Huge. Stellar interaction can lead to complex ecosystems in space, influencing everything from supernova explosions to the formation of new planetary systems. Speaking of planetary systems, did you know that not all stars are born in solitude? Many form alongside others, the forces between them shaping their eventual destinies. For instance, if a newly formed star finds itself close to another, their mutual gravitational pull can lead to star systems rich with planet formations. Our own solar system is a prime example of how stars create a playground for planet formation, a vibrant dance of celestial bodies influenced by their founding star's energy and gravitational might. However, the process doesn't end with birth. Stars also experience a life cycle that resonates with profound significance. As fusion continues within their cores, stars undergo several stages of growth and transformation. This phase can last millions to billions of years, making stars some of the oldest witnesses to the universe's story. Each star's life cycle encompasses episodes that might seem beautiful yet harrowing. There are periods of stability and explosions, romantic intersections with other celestial bodies, and ultimately, dramatic deaths that create spectacular events such as supernovae. Some remnants of these stars morph into white dwarfs, while others transform into neutron stars or black holes, inviting even more questions about the nature of existence. Let's take a moment to consider, why should we care about how stars form? Beyond the awe-inspiring beauty of the night sky, the formation of stars and their subsequent life cycles are fundamental to the cosmos' evolution and our own existence. It's thought that the materials we are made of, such as carbon and iron, were formed in the hearts of stars long before they exploded into supernovae, scattering these elements across the universe, thereby seeding planets and life. Every atom in your body that carries the essence of who you are may very well be stardust. Consider that for a second. You walk around as a bearer of the universe's history, intricately connected to every star that has ever burned brightly. However, our exploration isn't over just yet. After a star experiences its end, whether vibrant and expansive or compact and subtle, it leaves behind a legacy that can shape the future. When stars die catastrophically in cataclysmic supernova explosions, they forge new elements heavier than iron, gold, silver, and so much more. This means that the very jewels considered precious on Earth are forged in the explosive death throes of massive stars. So, those shiny trinkets on your hand could have formed from the remnants of a star that exploded billions of years ago. Isn't that an incredible thought? By now, you might be asking, how do scientists know all of this? Aren't we just observers in this grand cosmic play? Astrophysics combines theoretical understanding with empirical observation. Telescopes capture data from distant stars and galaxies, while experiments on Earth scrutinize the physical processes governing stellar formation. Each observation helps astronomers build theories, and sometimes surprise them with astonishing findings that flip our traditional understanding upside down. For instance, researchers have recently discovered that stars' tension between their own mass and the surrounding materials affects their life expectancy and the path of their evolution. Who would have guessed that the environment surrounding a star could influence its fate? As we consider the intricacies of stellar formation, let's dive into the cosmic scales, distance, time, and size. For perspective, our closest stellar neighbor, Proxima Centauri, is over 4 light-years away. This means the light you see from that dim star left it over 4 years ago, racing through the cosmos to reach you. And when thinking about time, remember that each life cycle of a star can take millions to billions of years. This vast interconnectedness leads to a realization: our universe is incredibly old, yet constantly changing. And just when you think it couldn't get more fascinating, consider the idea of dark matter and dark energy. These enigmatic elements comprise around 95% of our universe, influencing the structure and movement of galaxies. Although dark matter doesn't interact with regular matter the way we can observe, it plays a key role in clumping matter together, aiding in the star and galaxy formation process. Researchers are still unraveling this cosmic mystery, providing yet another layer of intrigue to the already electrifying narrative of star formation. Here's something you might not expect. Think about the universe on a grand scale. In the beginning, after the Big Bang, only hydrogen and helium existed in copious amounts. As stars ignited and evolved, they began cooking up the heavier elements that would eventually become planets, asteroids, and, naturally, life. This incredible cycle of creation and destruction means that every star is part of a much larger tapestry, one that illustrates our universe's continuous evolution and intricate relationships. So, what comes next in this cosmic drama? As our universe continues to expand, astronomers have recently turned their gaze to the earliest stars, known as population 3 stars. These primordial bodies, formed from nearly pure hydrogen and helium, represent an exciting window into the infancy of the universe, shedding light on the mystery of how galaxies and stars began evolving into the cosmos we know today. Insights into these early structures could reveal the unknowns of our universe's formative years and help us understand how today's stars and planets formed. Before we conclude our journey, let's reflect on some broader implications. Now you know how stars form, you can appreciate them on an entirely new level. They are not just lights in the sky, they are cosmic factories where every element in our body was born. Their story is our story, and understanding it adds depth to our existence. Not only do we share the same material threads as stars, but the cycles of their life resonate with cycles in nature and existence itself. As we step back to contemplate everything we've explored, remember the intricate celestial dance occurring in the vastness of space. Stars are born, live through awe-inspiring transformations, and die spectacularly. In their wake, they not only form new stars and planets, but they also weave together the fabric of existence itself, connecting everything, from the tiniest grain of sand on a beach to the massive galaxies swirling through the universe. Now, as we approach the conclusion of our cosmic exploration, take a moment to gaze up at the night sky once more. Each star you see is a remnant of an incredible journey of creation, a dazzling jewel in the tapestry of time. You now hold a piece of that story within you. Never forget that the universe has a rhythm, a pulse echoing in the vastness. In a universe exceeding imagination, filled with breathtaking wonders and mysteries, the question of how stars form underscores a deeper truth: we are all connected in this cosmic playground. And the journey of understanding the stars has just begun. After all, the night sky holds secrets waiting for you to discover. If you ever find yourself questioning your place in the cosmos, remember that in every star's birth and brilliance, there's a touch of our own story, waiting for you to reach out and embrace it with open arms. The cosmic dance continues, and every moment is a celebration.